All right, guys, today's another one of those days where we have two one-page notes at the same time. So the first one's on the left-hand side, page 30. It's called All About Slope, and then the next one is on just the opposite side of that, the right-hand side, and it is page 31, Parallel and Perpendicular Lines. All right, so first we want to talk about slope because we've introduced slope-intercept form and what that looks like, but what is up with the slope specifically. So the learning target is I can identify, compare, and interpret slope. So what we have here is just a couple sections of some things that you need to know. So the first one is invisible numbers, and this actually applies to all of slope-intercept form. So the two things that could happen is that if your numbers are being multiplied or divided, that means that the invisible number is the number 1. And if the numbers are being added or subtracted, that means the invisible number is 0. So here are some examples. So the first one I accidentally already did. But if you had it like this and there was no 1 there, it was just y equals x plus 7. Well, there's a number multiplying that x. And that's the number 1, right? They're being multiplied. There's 1x here. So that means that the slope, or m, is equal to 1, and the y-intercept, b, is 7. Okay, so now on to this one. Here we have y equals negative x plus 4. Well, I left a little space because between this negative and this 1, or this x being multiplied, is the number 1. So it's actually a negative 1 now. So now we know that the slope is negative 1 and that the y-intercept is 4. Okay, and then here we have that the slope, again, never include x in the slope, guys, is negative 6. But if you want to make it into a fraction, you can put it over 1 to create a fraction. And you'll see why later in the lesson why you might need to create a fraction when there isn't always already one. But sometimes you want your slope as a fraction. So you can just put it over 1. So that 1 is invisible. Any number can be over 1. And then you'll see my b value. Well, there's nothing there. Well, what does that mean? So normally the b value is added or subtracted. So that must mean that if it's being added or subtracted, it's an invisible 0. We're adding a 0. You don't have to write plus 0. You could, but you don't have to. So the b value is actually 0. And plus 0 and minus 0 is identical. Adding nothing or taking away nothing is the same. Great. Then we have the sign of the slope. So the sign refers to whether it's positive or negative. If it is a positive slope, that means that the line is increasing, or as we covered last topic, rising from left to right. So this is a little bit of a shorthand. L arrow R means left to right. Good. That's my thumbs up. Okay, if the slope is negative, that means that the line is decreasing or falling from left to right. All right, that's it for that section. Super simple. Okay, because essentially it's just bringing over from the rate of change of last topic. Then we have the steepness of slope, which again will refer back to rate of change for. And for this, what we want to do is ignore the sign. So drop that plus or minus, it doesn't matter, because what matters is what we call the magnitude of the number, or how big the number is regardless of plus or minus. So again, as long as you ignore the positive or minus sign of the slope, then the larger slope will have a steeper line. Okay, so just like rate of change, but you need to, again, drop the negative, because don't worry about comparing whether it's increasing or decreasing, because a decreasing line can be steeper than an increasing line, right? It can be really steep downhill and only a little steep uphill. Okay, so for example, which graph is steeper, y equals negative 5/3 x plus 6, or y equals 3/2 x minus 12? Okay, so the thing you want to compare is the slopes. That's all that matters. So we want to compare the slopes, but again, we want to ignore the positive and negative sign. So ignore the sign. So we're going to look at drop that negative. We just have 5/3 versus, and then 3/2 is already positive. So now I dropped that negative sign. We don't need it. Okay. Then we want to, in this case, probably want to convert these to decimals because then we'll actually have a better understanding of them. You might not need to, but I like to do it just to kind of get a better understanding. So convert to decimal if desired. Okay, so if you want to, go for it. So, we have, you can just do this on a calculator. 5 divided by 3 is what that means, right? Numerator divided by denominator, and you get 1.666666 repeating. So I'm going to write 1.6 with a bar over it versus, and then 3 divided by 2 is 1.5. So that actually helps me more because I can understand that 1.6 is actually going to be bigger than that. So that is actually the last step, is to, step 3, figure out which is bigger. So 1.6 repeating is going to be greater than, so I'm going to use the greater than sign, and you can see it's open towards that because the alligator eats the bigger number, 1.5. So this one's our bigger one. So you do need to remember that goes back to this one, and notice, oh, it did end up being the negative one. That does not matter that it was the negative one. What matters is that the magnitude, or if you ignore the positive and negative signs and just compare the numbers, this one's bigger. So that means that, thus, the graph of y equals negative 5/3 x plus 6, nothing to do with the y-intercepts, is steeper than y equals negative 3, oops, not negative, I'm sorry, just 3/2 x minus 12. Doesn't matter. Okay, so there you go. That is which one is steeper. Ignore the sign, convert it to the decimal form if you want, and then determine which one's bigger. If they ask which one's less steep, you'd want to find whichever one's smaller. Okay, the last part here is about zeros and the slope. So there's two options. Either 0 is in the numerator of the slope or 0 is in the denominator. Now, you're thinking fraction. Well, yes, because remember, slope is really just rate of change, and rate of change is a ratio. Either change in y over change in x, change in dependent over change in independent, y's over run. It's always boiled down to a fraction. So those are the options, numerator or denominator. So let's focus on numerator first. If the 0 is in the numerator, then the slope is 0, because 0 divided by a number is just 0. You can try that on your calculator, okay? The graph is a horizontal line. So if you think about it, positive numbers are rising lines or increasing. Negative numbers are decreasing. 0 is the number in between positive and negative. And what line is in between increasing and decreasing? Horizontal, okay? So it goes positive slope, positive slope, positive slope, positive slope, 0, negative, 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 okay? We consider it to have no steepness. It would be a nice Miss Azor walk because it's just nice and flat. And the equation of the line is y equals b. So notice that there's no x because 0 times x is 0. So that's just the y-intercept. Y equals b. That's it. We'll do more on that next time. But now let's look at when the denominator of the slope is 0. So then there's no slope, or you might say it's undefined. Okay, those mean the same thing, not like it's either or. You can say either of those things. And the reason for that is because you can't divide by 0. Sorry, I accidentally used a curly Z. So you can't divide it by 0, so it would be no slope or undefined. The graph is vertical, straight up and down, which we still don't consider to have a steepness. Okay, it would be like Spider-Man, who is the only one that can get up this wall, okay? Because it's got to be up a wall. And then lastly, its equation is x equals a number, let's call it a, and that would be the x-intercept, okay? And so when you have the notes, you'll see it's kind of like a comparative list of what the two parts are. Okay, so that is all about slope. Now let's go on to the next part. Okay, so now I'm on the right-hand side, page 31. This is parallel and perpendicular lines. And the learning target is I can identify and create pairs of parallel and perpendicular lines. Now, these are paired with our last notes because this has to do with slope. Okay, so we'll start with parallel lines. These are lines that never touch or cross, and they stay equal distance apart at all times. Okay, so they just run parallel to each other. They aren't even angled at all next to each other. No matter where you are, the two lines will always be the same distance apart. Now, it's related to slope, and in fact, if you don't have a highlighter, I would get out a highlighter and highlight this because they have the same slope but different y-intercepts. They can't have the same slope and the same y-intercept because then they'd be the exact same line. They wouldn't be parallel, they'd be identical, right? So they're the same slope but different y-intercepts, okay? So here's an example. The lines, oops, one thing I did forget to do. I left a space here on purpose, and that was to put kind of like a slanty 11. So this little slanty 11 kind of thing, it means parallel because it looks like little tiny parallel lines. So instead of writing the word parallel, I'm going to use this symbol, okay? It's just like a way to keep things shorter. So here it says the lines y equals negative 2x plus or minus 9 and y equals negative 2x plus 47 are parallel. So that word, that little slash thing means parallel. That's what you should say when you see it. Okay, and the reason these are parallel is because if we look at the form y equals mx plus b, then the slopes are negative 2. Remember, they don't include x, and that means our slopes are the same. So we have same slope. Okay, but we look here at the y-intercepts, which are the b part, so it's minus 9 and positive 47. We have different y-intercepts. Okay, so there you go. That's what you want to look for is this, and then make sure that those are different. So that is how you can identify it, but what about finding it on our own? So here it asks us to write the equation of the line that crosses the y-axis at y equals 7, which you could say the point 0.07, okay, and is parallel, so say the word parallel when you see that, to the line y equals negative 1/2 x minus 10. Okay, so as of right now, we need two things. Oopsie daisies, I almost knocked something over, guys, sorry. We need two things to write the equation of the line. Y equals mx plus b. So we need m, which is the slope, and b, which is the y-intercept. Well, lucky for us, it says right in here what my y-intercept should be. Okay, I'm going to abbreviate it to y-int, just because I can. So the y-intercept is 0,7, or b equals 7. Okay, so it just tells us right there what it is. That's easy. We don't even have to solve for it. Thank you, guys. You will have to later, but not right now. Now I need the m. Well, how do I find m? Well, what we know is we know it's parallel to this line, and parallel lines have the same slopes. So what I want to do is use this to help me find my slope. So again, y equals mx plus b. So the slope, oops, there we go, got to include that negative, is m equals negative 1/2. Okay, so now I have my b and my m. All I do now is plug them in to this. Y equals, and then instead of m, I'm going to put our slope, negative 1/2 x, oops, should have kept that the same color, it's fine, whatever, plus, and then 7. And it's 7 plus 7 because that's a positive 7, and there you go. That is it. just plugging it into the form of y equals mx plus b. So when it tells you it's parallel, then you know that they both have to have the same slope, so negative 1/2, negative 1/2, the original. Okay, now we'll go on to perpendicular. Okay, last part is parallel lines, and so I left a little space here to show the symbol for that. So it is an upside down capital T, and you'll see why in a second, because the parallel lines are lines that cross at 90 degrees or a right angle. So if you have an upside down T, then that creates two 90-degree angles. So that's why it's the symbol. And again, it's all about the slopes. So for perpendicular lines, slopes are opposite reciprocals. So notice, firstly, it doesn't say anything about the y-intercepts. The y-intercepts can be the same or different. It doesn't matter. All that matters is that the slopes are opposite and reciprocal. Well, what does that mean? Well, opposite means that the plus and minus sign are opposites. They're not the same. So that means that the signs of the slopes are opposite. 1 plus 1 minus, or 1 positive, 1 negative. Okay? That's what opposite means. Then we have reciprocals. Reciprocal means the fraction is flipped over. Okay, so remember how I said we like slopes in fraction form, not in decimal form typically, and you can always make something a fraction by putting it over 1. Remember the hidden number. So that would be like taking 2/3 and changing it to be 3/2. So we started with 2 over 3 and it becomes 3 over 2. That's a reciprocal. So you do both of those things and you have the perpendicular slope. So for example, before I move on, to check your work, a nice thing to do is you can multiply them and you should get -1. Okay, so if you did it right, when you multiply the two slopes together, you get -1. Okay, so here we go. For example, and you're going to see I used the symbol, and when you see the symbol, you say perpendicular. So the lines y equals 5 over 2x plus 9 and y equals -2/5 x minus 4 are perpendicular. Okay, well, why are they perpendicular? Well, if we look at this slopes, we have one is positive and one is negative, right? Because that one's negative, that one's positive. And they are flipped fractions. Okay, this is just the long way of saying opposite reciprocal. One is positive, one is negative, means they're opposites. Their flipped fractions mean they're reciprocals, because this one's 5 over 2, this one's 2 over 5. Okay, well, we can also do a quick little check. Our check says if we multiply the two fractions, so 5/2 times -2/5, we should get -1. So to take your fraction or your calculator, and remember, if you can either put the negative, there can only be one negative, so you can either make it negative out front, negative in the numerator, or negative in the denominator. I think I'm just going to put it in the numerator. So my first one is math fraction, nope. It's been a hot minute since I've done how to do it into a, there we go. Whoopsie daisies, I did not get it in the fraction. There we go. So the first one is 5 over 2, and then the next one is, oopsies. Azor, you're really bombing it here, aren't you? Here we go. 5 over 2. Fraction again. Negative 2. Again, you could put it out front. Just make sure you only do the negative sign once. 2 over 5. Oh, and wouldn't you know it, it's negative 1, even though it took me a hot minute to enter it in. Negative 1. Good. So that must mean that they are perpendicular. Opposite reciprocals, and they multiply to negative 1. Great. So we again have an example where we're going to write it, and it's actually exactly the same as the other example. I just used this symbol instead. So it says write the equation of the line that crosses the y-axis at y equals 7, which again means the point 0, 7, and is perpendicular to the line y equals negative 1/2 x minus 10. Okay, so again, I know that to write the equation of the line, I need to do y equals mx plus b, and I need to find m and b. Okay, now just like before, I have the y-intercept given to me. I know that the y-int is 0, 7, or you can write it b equals 7. That's what's going to go in for b. Now again, to get my slope, I need to use the fact that it's perpendicular to this, because it doesn't tell me the slope, but it gives me a clue, because I need to memorize what perpendicular means. So again, y equals mx plus b. For this, I only care about what the slope is. That's my slope. And that means I need to do opposite reciprocal. So m equals negative 1/2. Now, be careful. That's the slope of this right here. I need to find the perpendicular slope. Like, what is perpendicular to this? Well, we know that we need to do from above, opposite. So because this one is negative, this one's going to be positive. Okay, so I abbreviated that to up. And then reciprocal, I'm going to abbreviate to recip, means to flip this fraction. So it's 1 over 2, so I'm going to make it 2 over 1. Okay, but I can make that a little simpler. We don't always have to write the plus sign, and 2 over 1 is just 2. So now I know that my slope that I need to use is 2. So I'm going to come over here, and I have y equals, my m, or my slope, is 2x, and then because this is a positive 7, it's plus 7. And again, just to make sure that we did them correctly, we can do 2 times negative, and then do fraction 1/2. And I should get negative 1. Whoop, I do, so that is good. And there you go. That is the equation of the line that crosses the y-axis at 7 and is perpendicular to that line. All right, guys. See you in class.